A covalent bond is formed by the sharing of pairs of electrons between two atoms. We can think about this sharing as an overlapping of the s and p orbitals that hold the valence electrons. Other theories explain bonding in a more advanced way, and they're more complex, but they're beyond the scope of this introductory course. So we're just going to consider how the overlapping of orbitals would allow our electrons to be shared to form a covalent bond. Now, when electrons are being shared, we have to think about the different elements, because not all elements have the same attractive power for those electrons in the bond. And so we have something, a value called electronegativity. And on this sheet here I have the table of electronegativity. So if you look at it, there's all different numbers. If you look carefully, most periods as you go across, the electronegativity increases as you go across, and it increases as you go up. Fluorine with a number of 4 has the highest electronegativity. That means it has the greatest attractive power for electrons in a bond. Down here in the lower left-hand corner, we have the lowest electronegativity values, and these atoms would have the least attractive power for electrons in a bond. Now you may notice that the noble gases are missing from this table. The reason is because electronegativity has to deals with electrons in a bond. Well, noble gases in general do not form these as many bonds because they are already stable, and the formation of bonds is a way for atoms to become more stable. So they don't have electronegativity values. So how do these differences in electronegativity values affect the sharing and the formation of bonds? Well, let's take a look. We can look at the difference in electronegativity values to figure out the ways that our electrons are being shared in a bond. So here's a table up here that is just a general way of looking at the difference in electronegativity values between two atoms and the type of bond they would form. So let me do an example of each one. So let's say, for example, two nitrogens were forming a bond, and I'll just put nitrogen. A line is a common way to describe a bond. So nitrogen, if we look, has an electronegativity value of 3. So this nitrogen would have a 3, and this nitrogen would have a 3, and the difference would be 0, because 3 minus 3 equals 0. So basically, when they have the same electronegativity difference, they are equally pulling on those electrons and have equal attractive forces. So we get the case where the difference is less than 0.5, and this is what we call a nonpolar bond that shares equally. So if you have a difference of less than 0.5, your bond is nonpolar, and the word nonpolar means that they're shared equally within that bond. Well, let's look at an example where they might not share equally. So let's say, for example, we have a carbon and an oxygen bonded together. Well, we look, carbon is a 2.5 and oxygen is a 3.5. So if you look at the difference, 3.5, always taking the higher one first, minus 2.5 equals 1. So looking at the chart that I wrote above, we see that a difference of 1 falls between 0.5 and 1.9. And in this case, we have a different type of covalent bond. We have a polar covalent bond. And polar covalent bonds, the electrons are not shared equally. They're shared unequally. In fact, if we look at the two numbers, so carbon has a 2.5 and oxygen has a 3.5. So oxygen with a higher number has a greater attractive power. So if I drew a line, I could draw an arrow going this way. The electrons would be pulled toward the oxygen because it has a higher electronegativity value. Now another way they represent this is using the Greek letter delta. So they use, because electrons are negative and oxygen is pulling the electrons toward it, it becomes partially negative. And they use a Greek little delta with a negative sign. And then carbon, because the electrons are being pulled away from it, it gets a delta with a positive sign. In a polar bond, the element that has the higher electronegativity will always have a delta negative, or it will also be partially negative. This difference in having the partially negative and partially positive creates something called a dipole. A dipole. And a dipole just means two poles, or if you want to think about it, a positive and a negative end. Two poles, a positive and a negative one. And that occurs because it's a polar bond. Now we were talking about ionic compounds between metals and nonmetals. So let's take an example where calcium is with chlorine. So here's calcium and it has a 1.0. And chlorine has a 3.0. So if we subtract 3.0 minus 1.0, we get 2.0. And we see here a 2.0 that is greater than 1.9, and in that case there is no sharing. You're no longer a covalent bond, but you have an ionic bond. So the difference in the attractive power of the atoms, which can be illustrated by looking at the electronegativities, can determine if the electrons are shared equally and you have a nonpolar bond, or if they're shared unequally and you have a polar covalent bond, which then also has a dipole. Or if the electronegativities are so different that the electrons are not shared at all, but instead they're transferred, and you have an ionic bond.